Okay, what do you want to do first with this? You want to calculate pH, hydroxide ion concentration, or pOH? It's not 5. Okay. I would calculate the pH first. So I take the negative log of that 2.59 times 10 to the negative fifth. So what if this part right here wasn't here? What would the pH be, Brooks? 5. But with that part there, that means more acid. So what's the pH going to do? So what pH number are you expecting to see? 4 point something. That's exactly what you're supposed to see. So somebody got it? Just gonna grab somebody's homework. Does 4.9 sound good to everybody? What? Why would you do that?
What's the negative log of 2.59?
Is it? Writer begs to differ. Does anybody else beg to differ? That's not right. That's not right. That's not good enough. Now there's that. All right, I have confirmation. Karen and Ryder, same exact numbers.
It's 4.58.
4.58?
Yeah.
What?
6700.
Rounds up. 3 sig figs, we good with that? So 4.59, there's our pH. And from that, what can you get? Easy. So what do we get here? .9.401? And so from that 9.401, what can we do? Nice. So there's our pH, there's our pOH, and there's a hydroxide ion concentration. Is everybody okay with that negative 9.41? If you just punch that into the calculator, it'll spit out a times 10 to the negative 10th something or other with some numbers out front, if that makes you feel better. All right, how about the next one? I have a pH, so what can you get right away?
H plus.
H plus, sure. H plus ion concentration, 10 to the negative 2.36. And my pOH is 11.64. And then my OH negative concentration is 10 to the negative 11.64. All right, so what's important about this next question with the pH of the 0.2 molar solution? What should you recognize? Okay, I'm happy with that. Yep, it's an acid. Anything else about that acid? It's a strong acid. That's a strong acid. Why is that important? I don't have to check the chart. There's no chart checking. It's just 0.2. That's the concentration of H's in the water because it's strong, so it fully disassociates. So then I can just take negative log of 0.2 and get, what is it, like 0.7 for my pH. Okay. What's important about the next one? strong base, right? Okay, so this strong base, do I need to do any checking with anything? Any chart checking? No chart checking, right? Because it's a strong base, so then I just take, what happens when I take the negative log of this? I'm going to get 0.7, but this is not pH, is it? It's POH, because I just took the negative log of the OH concentration. So this is my POH, so then if I want my pH, I'm going to have to subtract that, so then my pH is actually going to be equal to 13.3. Why did I bold nitrous acid? Because I got to look at the chart, because this one's weak acid, right? So I need to see what the pKa is. And I didn't have to do that before because I didn't care to know what the dissociation was, because in all practicality, it's 100%. All right, so let's mosey on down there. Oh, not that far. Where is it? There it is. So nitrous acid, 5.62 times 10 to the minus fourth. So my Ka, He2, 5.62 times 10 to the minus fourth. All right. So what I have here is Ka is equal to Ha, H plus, A negative. What is this HA stuff? It's just the generic way to write down an acid. So the H part is obviously the acid part, and then the A is whatever the anion is, whatever the negative portion of this is. So what I know inside this equation is that my Ka is 5.62 times 10 to the minus fourth. I know that the concentration of my acid is 0.2 molar, and I don't know my hydrogen ion concentration or anion concentration, but I know they're the same value. So then I'm going to get X is equal to the square root of 0.2 times 5.62 times 10 to the minus fourth. So what's that concentration going to be equal to? Square root 0.2 times 5.62 e negative 4 close parentheses equals. I don't care. Go away. 0.106. So then pH. Wait, that's not right. For some reason. That's totally not right. 5.62 E negative 4. Close parentheses equals. Alright, so 0.0106. I get 1.97 for my pH. So remember, couple problems before, we had a strong acid and the pH was down to 0.7. Even though I have the same concentration of a weak acid, this thing is more than 10 times less acidic at the same concentration. Okay, so what's different about this next question? It's a weak base instead, but we approach the problem in the same fashion. So my weak base, my hydrazine, 1.26 times 10 to the negative sixth. 1.26 y square root 0.2 times 1.26 e negative 6 close equals negative log answer close equals. Alright, so I got 0.000502, and so then my POH is going to be equal to 3.3, and so then my pH is going to be equal to 11.7. Are we okay with that? How about 10.7? How about first grade math? That'd be good. How about this next one? Which one's stronger, the hydrocyanic or the acetic? So what am I going to need to look at? So my acetic acid concentration, or sorry, Ka is here, and my hydrocyanic is here. So which one of those two Kas is larger? The acetic acid. So how do you get a larger Ka? What does that mean? So the Ka is a fraction based off of reactants and products, and the bigger the number, the more products you have. And the products in an Ka would be H pluses. So I'm going to have more acid at the same concentration for an acetic acid solution than I would a hydrocyanic solution. So your answer is acetic because it's got a larger Ka. Nice. Okay, so I've got some pure water. So if it's pure water, its pH is 7. And what I want to do is calculate out the pH after I add 30 milliliters of a pretty dilute hydrochloric acid solution. So what I need to know is I have a container that's going to be 630 milliliters in size, and there's going to be a bunch of H pluses floating around inside of here, and so I need to know the number of H pluses that are going to be floating around inside of there. So if I take 0.15 moles per liter and I multiply it by 0.03 liters, I get 0.0045 moles of H plus. And so then if I take that value and I divide it by my 0.63 liters, I'm going to get 0.0045 divided by 0.63, and I get 0.007143, and so that's my H plus ion concentration. So then my pH will be equal to 2.15. Two. Looks like 1 sig fig. Are you okay with that?